Every year, more than 1 billion tons of corn are harvested, mostly in agricultural powerhouses like the United States, China, and Brazil, to feed the world's food, animal feed, and industrial needs. A significant portion of that is dedicated to the familiar breakfast food, corn flakes. Behind every spoonful of corn flakes lies an incredible, precise, high-tech processing journey. All will be revealed in today's video. Before the corn kernels can begin their journey to becoming corn flakes, they must go through an essential step, harvesting on vast fields. These large cornfields are harvested using modern corn harvesting machines, equipped with high technology to optimize yield and minimize loss. These machines automatically collect the corn from the fields, cutting the corn cobs from the stalks and separating them from the husks, all done with precision and speed. Modern machinery not only ensures efficient harvesting, but also reduces human exposure to environmental factors and risks. The sensor and GPS systems on the harvesting machines help accurately locate the corn plants, ensuring no cob is left behind. Once the harvest is complete, the corn is transported in automated transport vehicles, quickly moving it to the processing plant for the next steps in production. Harvested corn is fed into a hopper, which then transfers it to a high-performance integrated conveyor system. As the corn cobs move along the conveyor, an advanced laser scanning system scans the entire surface of each cob to detect defects, foreign objects, and color differences. In this integrated process, the two ends of the corn are marked with a laser, then transferred to a closed rotary cutter with a sharp blade that cuts both ends evenly. The remaining corn falls into rotating drums where the corn kernels are forced to roll, collide with each other and against the drum walls, removing the husks and impurities that remain on the kernels. In addition, the rotating mechanism helps prevent the corn from getting stuck or clogging as it moves along the conveyor. In the non-laser method, corn cobs are manually placed on a conveyor belt to pass through processing steps such as a double blade rotary cutter and a section cutter. After cutting, the corn sections leave the machine and move to the next processing stage. At the rotating distribution table, the corn cobs slowly slide to the beveled edge, then fall into troughs below, helping to evenly distribute the cobs to the next processing step. In the other method, the harvested corn cobs are lined up and sent to a sheller. Inside the machine, rotating brushes pull and separate the husks from the corn cobs, which are then transported by a separate conveyor to a waste container. The clean corn cobs are placed in a temporary container, helping to coordinate between stages. Trained workers carefully inspect them to remove any remaining impurities or foreign objects. The cobs then enter a rotating washing drum, which uses high-pressure water jets to rinse the entire surface as they rotate inside. In another method of processing, the corn cobs are transported from the temporary storage bins via a conveyor system to a kernel separator. This machine uses specialized blades to peel the kernels off the cobs. These separated kernels are transferred via chutes to the storage bins, which are then loaded onto trucks via a separate conveyor. At the mill, corn kernels are unloaded and brought to a receiving area where they are transferred to large hoppers. Here, they are fed into rotating drums for mixing, then passed through air classifiers to separate dust and light impurities from heavier kernels. The clean kernels are then fed into a multi-stage grinding process, using specialized machinery to produce corn grits and cornmeal. The milled product is sent to large silos for storage, while the byproducts are collected separately for use in animal feed or oil extraction. Semi-automated cornflake factories use a combination of manual and mechanical labor. After the corn kernels have been cleaned and processed, they are fed into a rotating cooker where water and flavoring agents are added during the cooking process. Once cooked, the kernels are transferred to a rotating drum washer where a controlled water spray removes any remaining residue. The wet kernels are spread out on trays and allowed to cool before being pressed into flakes by rollers. This is followed by air drying, after which the flakes are baked in batch ovens to achieve the familiar crispness and golden color. The final product is cooled, manually inspected, and manually packaged into bags for distribution. In contrast, highly specialized cornflake plants rely almost entirely on automation. From bulk storage, corn kernels are transferred to pressure cookers where they are washed and cooled by blowers that circulate cool air around the rolling flakes. Flattening is accomplished using precision rollers, and moisture is managed in continuous dryers equipped with smart sensors. The toasted flakes are then passed through automated optical scanners that detect defects and grade them accordingly. These facilities can also produce cereal rings by mixing cornmeal with sugar, flavorings, and coloring, then extruding the mixture into rings before baking and packaging. Finally, the cereal is air-cooled and sent to the automated packaging area. A multi-head weigher accurately measures each portion to be filled into bags on a conveyor belt. Once filled, the bags are sealed with an automated heat sealer to ensure airtightness and freshness. This process of transforming corn into seamless popcorn shows the magic of modern food production, combining agricultural science with industrial engineering. If you find this behind-the-scenes look at the world of popcorn production fascinating, be sure to like the video, subscribe to the channel, and hit the notification bell for more in-depth information on how to make your favorite foods. Welcome back to our channel, where we will explore the journey of growing, harvesting, and processing spirulina. Known as a nutrient-rich superfood, spirulina is packed with protein, vitamins, and antioxidants. With increasing demand, spirulina is being produced globally. Let's dive into each step of transforming this microalgae from its microscopic form into a valuable health supplement. Spirulina, whose scientific name is Arthrospira platensis, thrives in warm alkaline water environments, making it highly suitable for cultivation under carefully controlled conditions. The majority of spirulina farms are situated in regions with plenty of sunlight and consistently warm temperatures, factors that are essential for its optimal growth. These farms are generally located in tropical and subtropical areas, including countries such as India, Thailand, and parts of the United States. The first step in cultivating spirulina is preparing the ponds or bioreactors. Open ponds are shallow water bodies that allow sunlight to stimulate photosynthesis, supporting spirulina's growth. In contrast, closed bioreactors offer precise control over light, temperature, and nutrients while protecting the spirulina from contamination, where LED lights are often used to ensure the algae receive enough light for photosynthesis. Once the cultivation system has been fully established, the process of growing spirulina begins. The water where spirulina is cultivated must be enriched with all the essential nutrients it requires. Spirulina absorbs these nutrients during the process of photosynthesis, converting sunlight and carbon dioxide into energy, which allows it to grow at a very rapid pace. Farmers introduce spirulina cultures into the growth environment, and under favorable conditions it multiplies quickly. Within a few weeks, what started as clear water transforms into a thick, dark green mixture filled with microscopic spirulina cells. The color of the water indicates the algae's density. As spirulina grows, the water changes from light green to deep blue-green, signaling it is ready for harvest. When spirulina reaches its maximum density, typically after a few weeks of growth, it's time to harvest. This must be done carefully to avoid damaging the delicate spirulina cells. In open ponds, spirulina is usually harvested through filtration or centrifugation. Filtration involves using fine nets or cloth to separate spirulina from the water. This process begins by passing the spirulina-laden water through a special cloth with tiny holes. These holes are small enough to let the water pass through, while spirulina, being larger, cannot. As a result, much of the water is separated from the original solution. Next, workers continually scrape the surface of the cloth with a spatula, applying slight pressure to increase efficiency. Over time, the spirulina paste becomes increasingly thick, and the process continues until it reaches the desired consistency for transitioning into a solid state. The next step is dewatering the spirulina. One common method is spreading the spirulina mixture onto large drying tables, where it is exposed to airflow and low temperatures to evaporate the water. At some farms, spirulina is placed in special bags that allow water to seep out while retaining the algae. These bags are then pressed under high pressure to force out the remaining water. This process produces a dehydrated spirulina sheet. After every last drop of water is pressed out of the spirulina paste, the mixture turns into a thin, brittle sheet that still retains some moisture. To completely eliminate this remaining moisture, the spirulina sheet is ground into smaller pieces and fed into a cylindrical device. This device uses high pressure to compress and push the sheet through tiny holes, transforming it into small fiber like strands resembling noodles, which enhance the material's smoothness and uniformity. Afterward, the spirulina strands are placed on trays to undergo complete drying. This stage may utilize temperature-regulated equipment or specialized machinery designed to ensure that the spirulina dries evenly and consistently. Once the drying process is fully completed, the spirulina transforms into a hard and firm state, making it ready for the subsequent steps in the processing stages. After drying, the spirulina fibers are prepared for the final transformation. Depending on the manufacturer, these fibers may be ground into powder or compressed into tablets. Spirulina can be used in a variety of different foods such as soups, smoothies, and even desserts like cakes or ice cream. Due to its high nutritional content, many people choose to incorporate spirulina into their daily diet to enhance their health. It can be added to nutritious drinks or combined with main dishes, creating a diverse and healthy menu. Additionally, spirulina can be processed into capsules for easy consumption, particularly in nutritional supplementation regimens for vegetarians, the elderly, or those seeking to enhance their health. Furthermore, spirulina supports detoxification, reduces inflammation, and helps improve digestive issues. Many studies also show that supplementing with spirulina can help lower bad cholesterol, support blood sugar regulation, and prevent chronic diseases such as cardiovascular disease and diabetes. As we conclude our documentary on spirulina farming, we hope you found it interesting to learn about the detailed and fascinating process behind this superfood. Stay tuned for our next video where we will dive deeper into agriculture. Don't forget to like, share, and leave your comments. Thank you for watching.